What if the lights went out across the entire country? Not for hours, but for days. Over 70% of America's transmission lines and transformers were built in the 1950s and 60s, long past their design life. At the same time, electricity demand is exploding, driven by AI data centers, electric vehicles, and factory electrification. NERC now warns of elevated or high risk of energy shortfalls across huge regions. Blackouts could become far more frequent by 2030.
I'm here where the old grid meets the new crisis. A $1 trillion engineering overhaul is now underway.
Utilities are entering a supercycle. $1.4 trillion in new spending from 2025 to 2030, double the last decade. This isn't just patching wires, it's full re-engineering. High-voltage DC lines, AI-controlled grids, and infrastructure hardened for the 21st century. These lines will carry clean power thousands of miles with almost no loss. But can the overhaul outrun the crisis that's already here?
The next decade will decide if America keeps the lights on. In this film, we go inside the control rooms and construction sites.
This is the $1.4 trillion gamble to keep America powered. The story is just beginning. February 2021. Texas froze for 6 days. The grid failed. Over 240 people died. Economic losses topped $130 billion. That was one storm, one state. Experts now warn similar failures could hit multiple regions simultaneously, and the triggers are multiplying. Aging lines have ignited deadly wildfires in California. Extreme heat, hurricanes, and cyber attacks are all testing the same fragile system. Operators are forced to make split-second decisions with 1950s-era tools while demand skyrockets.
The question is simple. Can a $1.4 trillion overhaul fix this in time?
Data centers and EVs are adding the equivalent of entire new states to the grid every few years. The solution: high-voltage direct current lines that move power 1,000 miles with almost zero loss, something alternating current can't do. AI is now watching every transformer and line in real time, predicting failures before they happen.
These tiny sensors are the eyes of the new grid, but replacing 70% of the system while demand explodes.
The race is on. We're going inside the control rooms, the factories, and the secret test sites where this $1.4 trillion bet is being decided. The biggest hidden crisis inside the $1.4 trillion overhaul? We're critically short on large power transformers, the size of shipping containers that cost millions each. Each one takes up to 2 years to build. Right now, America needs 500 more, immediately. But global supply chains are still recovering from the pandemic. If a major storm or cyber attack hits tomorrow, utilities have almost no backup transformers. This is the single point of failure that keeps grid engineers awake at night. The good news? New American factories are finally coming online, but even these won't reach full production until 2028.
We're spending $1.4 trillion, but the transformers we need most still take 2 years to build.
While factories catch up, utilities are also building the superhighways of electricity, HVDC lines that can move power from sunny Texas to cloudy New York with almost no loss. AI now predicts overloads 30 minutes in advance and reroutes power automatically. Technology that simply didn't exist a decade ago. But there's a new threat: state-sponsored cyber attacks. The grid is now a digital battlefield, and the next attack could be far worse than 2021.
The only question left is speed. Be outrun and hurried.
The race is now measured in months, not years. What happens next will decide if America keeps the lights on for the next century. Before any new equipment goes live, it's tortured here. 500,000-volt short-circuit tests that simulate the worst storms and cyber attacks imaginable. These tests are revealing exactly which 1960s designs will fail first, and which new designs can survive a direct hit from a Category 5 hurricane or a cyber pulse. In high-risk areas, utilities are burying new HVDC lines underground, immune to ice storms, wildfires, and even some cyber attacks. Giant battery farms are now the shock absorbers of the new grid, storing excess solar and wind power for when demand spikes or lines fail.
Batteries give us minutes to hours of backup. But the real game changer is learning to have power across the entire country.
This single $2.5 billion line will move wind power from the heartland all the way to the southeast, the first true superhighway of the 21st century grid. In real time, the AI decides which hospitals stay online and which factories temporarily shut down. decisions that used to take humans hours. These men and women are the front line of the overhaul, working 12-hour shifts in every kind of weather to rebuild America's backbone.
We have the vision, we have the technology, but the human reality is this. We need thousands more skilled workers, and we need them yesterday.
The trillion-dollar gamble is halfway built, but the real test and the real danger is still coming. A new danger has emerged: state-sponsored cyber attacks. In 2024, hackers nearly breached the grid in multiple states. The next attack could be far worse than any storm. The grid is now a digital battlefield. One successful attack could black out entire regions for weeks, and the tools to defend it are still being built. Even bigger than the tech gap is the people gap. America needs 40,000 more skilled linemen and engineers in the next 5 years, and we're training less than half that number. These are the men and women who keep the lights on. Average age, 48. Retirement wave is coming, and the pipeline of new workers is dangerously thin.
We can spend $1.4 trillion on steel and silicon, but without the people to install and maintain it, the new grid will...
I've been climbing poles for 38 years, says veteran lineman Mike Reynolds. My crew is retiring faster than we can replace them. If we don't fix this, the grid fails, no matter how much money we throw at it. Utilities are now offering $100,000 signing bonuses and free apprenticeships. But even that may not be enough to close the gap in time. This is the human side of the trillion-dollar gamble. The next generation that must literally climb into the sky to keep America powered.
The steel is rising, the AI is watching, but everything depends.
We're now at the midpoint of this story, and the most surprising twist is just ahead. Here comes the twist almost no one outside the industry has heard about. It's called advanced reconductoring. Utilities are quietly replacing the old wires on existing towers with new composite core cables that can carry up to twice the electricity, without building a single new tower. 1 mile of reconductoring costs about 1/10 as much and takes months instead of years. Dozens of projects are already live from California to the Midwest. Add dynamic line rating sensors, and the same wire can carry 30 to 50% more power on hot days, all using technology that already exists today.
We don't have to rebuild the grid from scratch. We can double the capacity of
Projects like these are already online in Texas, California, and the Midwest, delivering results years ahead of schedule. One utility engineer told us, "We just doubled the power on a 50-mile corridor in 6 months. That used to take a decade." This is the midpoint revelation. The trillion-dollar overhaul isn't just about building new. It's about unlocking hidden capacity we already own.
For the first time, the math is starting to work in our favor. But this is only half the story. The final chapter will decide if these games...
The hardest part of the journey is still ahead. Stay with us. The final test is coming. Even with the money flowing, the supply chain is choking the entire overhaul. Over 80% of large power transformers still come from overseas, and global lead times are now 3 years. Domestic production is finally ramping up, but it's years behind schedule. One delayed ship from Asia can push a $400 million project back 18 months. Permitting delays are the silent killer. Average approval time for a new high-voltage line, 7 to 10 years, longer than it took to build the Hoover Dam. Lawsuits, local opposition, and endless environmental reviews have killed or delayed projects worth tens of billions. The grid can't wait, but Washington still moves at 1950 speed.
We have the technology. We have the money. But bureaucracy and politics are now the biggest obstacles.
And the clock is accelerating. Climate scientists now predict 50% more days of extreme heat and storms by 2035. Exactly when our new grid must be ready. The new infrastructure must survive conditions the old grid never faced. One bad season could wipe out years of progress. We're not just rebuilding an old grid. We're engineering one that must survive a climate we've never lived in before.
The engineering is world-class. The money is committed. But Mother Nature and Washington bureaucracy are racing us to the...
Act 2 ends here, with the tension higher than ever. In the final chapter, we discover if this trillion-dollar bet will pay off, or if the lights go out for good. The first wins are already here. In Texas, one reconductoring project finished 6 months early and is now quietly moving enough extra power to run 200,000 homes, using the exact same towers that stood for 60 years. Dynamic line rating sensors are adding another 30% capacity on hot days. Free extra power from lines that already exist. Washington is finally moving. The 2025 permitting reform law cuts approval times from 10 years to 3 for critical grid projects. The biggest regulatory breakthrough in decades. Projects that were stuck since 2018 are suddenly breaking ground. The logjam is breaking.
Is finally flipping. The $1 trillion overhaul is no longer just a plan, but canon. It's becoming reality.
I've been in this business 28 years, says lead engineer Dr. Rachel Kim. For the first time, I actually believe we're going to make it. The next generation is climbing faster and smarter than we ever did. They're not just fixing the grid, they're future-proofing it. Domestic manufacturing is finally scaling. By 2028, we'll produce 80% of what we need right here in America.
Coming together. The old grid that almost failed us is being reborn stronger, smarter, and more resilient than ever before.
The final chapter is now being written. And for the first time in decades, America has a real shot at keeping the lights on. Not just for today, but for the next 100 years. The winds are stacking up faster than expected. In Arizona, a new solar farm came online 6 months ahead of schedule and is already feeding clean power into the upgraded lines. The same story in Kansas. Wind power that used to be stranded is now flowing 800 miles east without losing half its energy. During last summer's heat wave, battery farms in California kept the lights on for 1.2 million homes when the old grid would have failed. The new hardened design survived Category 4 storms that would have knocked out entire regions just 5 years ago.
This isn't theory anymore. Neighborhoods, factories, and entire cities are already running more reliably than they did a decade ago. And from the city, let's check in with a
For the first time in generations, small towns that lived with rolling blackouts now have stable power and real economic hope. The grid is now defended by AI that stops attacks in seconds. Technology that simply didn't exist when the old system was built. Politics finally aligned. Faster permitting and domestic manufacturing incentives are turning plans into steel and power. What was once a fragile patchwork is becoming the strongest, smartest power system on Earth. The $1 trillion gamble is paying off, but the final test, and the real payoff, is still coming in the next 3 minutes. Geothermal plants like this one in California are now running 24/7, providing baseload power that never stops, no matter the weather. Modernized hydro dams are now storing excess renewable energy and releasing it exactly when the grid needs it most. AI is now balancing the entire country's power in real time, moving electrons from wind in Texas to air conditioners in New York instantly. These giant batteries are the new shock absorbers, storing solar power all day and releasing it at night when America needs it most.
We've gone from crisis to confidence in less than 5 years. The grid that almost failed us is now stronger, cleaner.
I've spent my whole career fighting blackouts, says veteran engineer Linda Morales. For the first time, I can say, we're going to win. Ordinary Americans are now part of the solution, generating their own power and selling it back to the grid. Offshore wind is now powering millions of East Coast homes, clean energy that the old grid could never have delivered. And just over the horizon, fusion power, the ultimate clean energy source that US labs are now bringing closer to reality every year. The $1 trillion gamble is working. America's lights are staying on, brighter, cleaner, and more reliable than ever before. Last summer, when temperatures hit 110 degrees across the Southwest, the old grid would have collapsed. This time, nothing happened. Factories that used to shut down during peak demand are now running non-stop, creating jobs and keeping the economy strong. Hospitals that once feared losing power during storms now run without a single flicker. No rolling blackouts, no emergency alerts, just normal life, because the grid held.
Normal. The crisis didn't win. America did.
We didn't just fix the grid, we rebuilt it for the century ahead, stronger, smarter, and ready for whatever comes next. The next generation is already climbing higher than we ever thought possible. This is no longer a gamble. This is America's new backbone, built to last.
The lights are on. The future is powered. And for the first time in a long time, America is ready.
This is the new American grid, built by us, for us, and for the generations who will never have to wonder if the lights will stay on.